Okay, now let's consider this problem. Consider the configuration below. The B field is 1 Tesla and the rod B field is 1 Tesla. The rod speed is 10 meters per second and the rod's length is 0.1 meters. What's the induced EMF of the circuit? If the resistor has a resistance of 2 ohms, what is the force needed to move the rod at constant speed? Alright, so let's get started. Okay, so the first thing is let's calculate EMF. The EMF is going to be equal to minus d phi dt, where this is the magnetic flux. Right? And the magnetic flux is just phi is equal to B times A in this case, right? So this is just going to be equal to minus d by dt of B times A. Now B is a constant B field, so 1 Tesla. So this is just going to be equal to minus B times d by dt of A. And what's A? A is just this area here. That's A. And that A is just basically some length in this case, which we'll call X, and then some width, which is in this direction, which is the rod's length. So this length, this width right here is 0.1 meters. Okay, so this is going to be equal to minus B d by dt. This was L again, say. This is going to be L, which is a constant, times X, which is the displacement, which is the size, the length of this thing, the rod along the two wires. And if you apply d by dt on this thing, you get basically this thing's a constant, so that will not contribute. So this will contribute. So it's going to be equal to minus B times L dx by dt. And what is that? That's just simply velocity. So it's going to be minus B LV. Alright. So now we can go ahead and plug things in. Alright. So this is just going to be 1. And then the rod's length is 0.1. And the rod's speed is 10 meters per second. So that's 10. Alright. So that's minus 1 volts. Alright. And then basically we want to draw the EMF. The EMF is going to be basically somewhere in that direction. It doesn't matter anyway. So this potential drop here, this potential drop across this resistor now is going to be 0.1 volts, which is what we're going to need. Okay, so that's part A. Okay, now for the second part, okay, the resistance. So if the resistance R is equal to 2 ohms, we can then calculate what the power dissipated in this resistor has to be. And once we know what the power dissipated in the resistor needs to be, we will need to know what the force is going to be in order to move this thing at constant velocity. So let's go ahead and do that. All right, so in order to do this, we're going to basically get the power in the resistor. That's just going to be, in this case, the EMF squared divided by R. All right. Another way to think of it is the EMF times I, but this is just EMF over R. So it's going to be EMF squared over R, and that's just going to be minus 1 squared divided by 2. So that's basically 0.5 watts. All right. So once we have that, we will now know what the force is required in order to move this at a constant velocity. So the force, the power, is equal to force times the velocity. So this is equal to force times what's the velocity? It's 10 meters per second, so that's 10. And this is going to be equal to the dissipated power in the resistor. So this is equal to the power dissipated in the resistor, which is 0.5. Right? And so you can go right ahead and figure this out. Force divided by 10, that's 0.05 newtons. And that will be the force required to move this at constant velocity.